Hi and welcome to a video all about congruent triangles on Kirby Maths. So the first thing we need to do is know that the word congruent means identical, and in a question involving congruent triangles they will not use the word identical, they will always say congruent. Congruent shapes are exactly the same as one another, the side lengths are the same, the angles are the same, and basically the test is that if you could cut it out and flip it over or turn it round, you could lie the two shapes one on top of each other and they would fit exactly. So congruent is sometimes used with other shapes as well, hexagons, rectangles, squares, but usually proofs for congruent triangles are where you would come across the word congruent. So there are four reasons why a triangle would be congruent with another triangle. The first one, and we use three-letter abbreviations for each one, the first one is that all three sides would be the same. So if you have a triangle and all three sides in triangle A are the same as all three sides in triangle B, then those two triangles are identical to one another. You can only have those two triangles that look like that. You could cut them out, lay them over the top of each other, and they would be identical. The second condition for congruence is side, angle, side. And you can see from this diagram down here that it's two sides and the included angle. So we've got side A along here and side A along here. We've got the angle in between A and B here, and then side B there. Now if you were to cut those triangles out, obviously mine are just sketches so they're not congruent, but if you were to cut those triangles out and they had those exact measurements, then that would lie exactly on the top of that one. So this is abbreviated to SAS, side, angle, side, the two sides with the angle in the middle. The third condition for congruence is if you have two angles that are the same and one of the sides in the triangle in the same position, then those are also congruent triangles. And what we mean by a corresponding side, so that's the side in the same position, is we've got our two angles here. So we've got A, and at the other end of this line we've got B. And can you see in this triangle that the side I've marked as X is next to B and opposite A? And the same is true in this triangle, even though it's the other way up. It is next to B and opposite the angle, and that is abbreviated to AAS, angle, angle, and a corresponding side. And finally, we have the condition which is called RHS, which stands for right angle, hypotenuse, and side. So if you have a triangle with a right angle, like we've got here, and you are given the hypotenuse, the side which is opposite the right angle points towards the hypotenuse, and you have one other side in each of the triangles and they're equal, then that is a condition for congruence. You could say that those triangles are identical to one another. You need to learn these four abbreviations and be able to apply them. So I'm now going to go through 6 examples where we're going to apply these 4 conditions. On this first example, I am looking at the fact I've got a side here that's 4 and a side in this triangle that's 4. I've got a side that is 5.5 and another side which is 5.5, and in between them there is a right angle. It is tempting, if you've got a right angle, to use right angle hypotenuse side, but in this case I would be using side angle side, because the 4 centimeter side equals the 4 centimeter side. The right angle is in between that, and the 5.5 centimeter side is equal to the 5.5 centimeter side. So those two triangles are identical. You can only have one triangle in the whole world that has a 4 centimeter side here, a 5.5 centimeter side here, with a right angle in between it. This next one across here, we have got a side, we've got a right angle, and we've got another angle. The side lies between these two angles. So we have got here angle, angle, corresponding side. So this is angle, angle, and corresponding side. The side is in between the 55 and the right angle, 55 and the right angle, and the angles are the same in each triangle. In this example, we have got a hypotenuse in both triangles because the right angle is pointing towards the hypotenuse, and that is the same in each triangle. We have got a right angle because that's marked in our triangle, and we have got another side in the triangle. So the condition for congruence here is right angle, hypotenuse, and side. On this one, we have got 55 and 35, 55 and 35, and then we've got the side. The 5.5 is opposite the 55, and it is also the same here. So here we have got, again, angle, angle, and corresponding side. I'm going to come back to this one in a minute because there's a common misconception that we need to make sure that we don't make a mistake when we're doing congruent triangles. On to the ones at the bottom then. Let me just move that up a bit. We have got a 4 centimetre side, a 4 centimetre side, a 5.5 centimetre side, a 5.5 centimetre side, and a 6.8 and 6.8. So this condition for congruence is side, 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 because all three sides are the same. And finally, here we have 5.5, 6.8 with 35 in between them. 5.5, 6.8 with 35 in between them. So this is side, angle, side. SAS, the side and the angle in between them, the included angle. If I just go back to this example, it is quite tempting to work out this other angle, which would obviously be 90 degrees, and then you would have three angles that are the same. But angle, angle, angle is not a condition of congruence. And you have to be really careful of that, because if you have angle, 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 same in a triangle, you could have a small triangle like this, which had an angle here of A and an angle here of B. And then you could draw a bigger triangle. You could enlarge that triangle, maybe by a scale factor of 2 or 3. Right angle here. A would still be the same, because remember the angle sum of a triangle is 180 degrees. That doesn't change. If you double the side lengths, you multiply everything by 2, you don't increase the angles by 2. They stay exactly the same. So you must not use angle, 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 because that does not show that your triangles are unique with each other. Okay, finally, I just want to go through how you would write out a proof for congruent triangles, because you're often asked to prove that triangles are congruent, in which case you have to write out things in a certain way. So with this first one, we've got an equilateral triangle, and that means that all these sides are the same length. Difficult because I've cut that one in half. And it says that AD is perpendicular to CB, and the diagram already had a right angle marked on there. If it didn't, you could mark that on, because perpendicular means at right angles to. And we are asked to prove that ABD, the triangle ABD, which is this triangle ABD, is congruent to ADC. So they're asking you to show that those two triangles are identical. So the way in which I would do this is I would look for these two sides being the same. So AB is equal to AC, and that's because it's an isosceles triangle. AD and, ADB and ADC, those angles equal 90 degrees. And if you're writing this out, you would write given, and that's because you are given that in the question that it's perpendicular, so it's telling you it's a right angle. And finally, and this is the kind of trick that you need to look for often in a congruent triangle question, AD, the line AD is common to a triangle ABD and triangle ADC. And that is the phrase we use if they both share that same side. Then we can look for our conditions of congruence, and in this case I'm going to use right angle, hypotenuse, and this common side. So therefore, our three little dots, therefore triangle ABD is congruent with triangle ADC, and the reason is right angle, they've both got a right angle in them, they've both got the same length hypotenuse, and they share that common side AD, so that is also in both triangles. So when you're writing a proof, you're looking to tell the examiner or the person who set the question what things you notice about these triangles that are the same. And sometimes you can notice lots of things and then end up not using them, but it's better to write them all down than leave them out. If you're given something, that could help you, so don't, just because you're given it, don't forget to write it down, because that is part of your proof on the congruent triangles, is that you have got a right angle. And also watch out for lines which are common. On the second example, again, we're going to use a common line. So this is a kite, and we're asked to prove that triangle ABC, this triangle ABC, is congruent to triangle ACD, the other half of that kite. So the first thing we need to do is work out or write down things that are obvious from the diagram. Now, this is a kite, and one of the geometric properties of a kite is that these two sides, AB and AD, equal each other. So we write that down. AB equals AD, and you could just write two sides on a kite are equal, and they were already marked in that they were equal in length. The second two sides, BC and DC, they are also equal, because that is the other property of a kite, that those bottom two sides are equal. So write it down. BC is equal to DC. And here I'm just going to put those quote marks, because it's exactly the same reason. The final thing that you may actually have to draw in, it was already on the diagram that I copied, but you might want to split this whole kite in half, and then you've got a line that is common to both these triangles. So AC is common to triangle ABC and AC, triangle ACD. And then we have our condition for congruence, that this side is the same as this side is the same as this side, and they share this side. So the conditions for congruence is side, side, side. So we write down, therefore, triangle ABC is congruent with triangle ACD, and the reason is side, side, side. You don't even have to write the word, you can just write SSS. And sometimes at the end of a proof, if you're asked to prove something, you could write as required or as rect. Okay, so there's a lot to think about in this video. The best thing probably to do is go back, have a look at the reasons when I've explained the reasons, pause, make sure that you're happy with that. Then look at my 6 examples and paying particular attention to the fact that you must not use angle, angle, angle. That's not a reason for congruence. And finally, pay very close attention to how I've written out the proof for these two particular questions. It's all about writing down what is obvious and what is in front of you that will get you the marks in a congruence question. Thanks for watching.